Welcome back to the Automation Podcast. My name is Shawn Tierney, and this week on the Automation Podcast, I meet up with Ron Knight from Prism Systems and John DeTellem from Siemens to learn all about the new cause and effects matrix language inside of TIA Portal version 17. John and Ron, thank you both for coming on the Automation Podcast to talk about the cause and effect matrix. I know, John, you have been on several times and you did cover this in the V17 Update podcast, which I think was our #1 podcast from last year, our biggest hit. And so thank you, John, for coming back on the show. Ron, even though you and I have bumped into each other over the years, I think this is your first time on the podcast. So could you just take a moment to introduce yourself?
Sure, Shawn. My name is Ron Knight. I work for Prism Systems. Prism is a Siemens certified solution partner headquartered down here in Mobile, Alabama. And Shawn, that's sort of where you and I met way, way back in the day here in Mobile.
Yeah, down there when I was working for Stewart C. Irby Company, great folks down there. I know that they're not located in that same location anymore, but you guys were one of our favorite customers. And of course, John, what's your official title? I know you're in charge of like TIA Portal, but what would be your official title at Siemens?
Sometimes I like to keep it simple and just say TI Portal Promoter. Keeps me out of trouble.
I love it. I love it. So let's go ahead and start talking about this because this cause and effect matrix is something that I think is a differentiator for Siemens. I haven't seen anybody else doing this. And it's interesting and new. And I think we have a lot of PLC programmers who listen to the show. I just heard an engineer who has 40 years in the business said he was just listening to the podcast. So we have a lot of people like that who are listening. And can you give us kind of an introduction of what this is?
Yeah, I'll go ahead and give an overview. Basically, it's the objective is to simplify kind of the look and feel of some key permissives as they roll through a matrix and drive some key effects or outputs, and potentially change up the traditional bit type or even some analog ladder logic and make it potentially more simple for a viewer that isn't necessarily in the need of running through ladder logic. So there used to be fail-safe matrices that were used in Excel, for example, to kind of define what permissives were required and then run through a condition matrix where you either require all the conditions to be true or 1 out of 2 to be part of it. But basically what they did within the TI Portal PLC language editors is extended ladder, FBD, the scripting languages, and graph, and they created a new editor that is exactly that. It's basically got causes where I define my inputs to traditional logic instructions like and, or, greater than, equal, and then run through a matrix where I check it with other conditions and drive an output.
Yeah, it's interesting. And for the audio only audience, what we're looking here is on the left-hand side of the screen, we have in a column causes. And then along the top, we have effects. And so these play together to step us through the logic. And I know, Ron, you're actually using this in an application. Can you tell us a little bit about how you went about using it the first time?
Yeah, so a lot of times when a customer gives us a process narrative, and this is particularly popular in like natural gas facilities or water wastewater facilities, they'll actually give us a cause and effect matrix. So if you get a high level in this tank, then you should shut down this pump. Or if you get a high temperature in this tank, you should interlock this steam valve. And it's in a sort of what John described, it's in an Excel workbook with causes on the left, effects across the top, and the process engineers, they don't really know ladder logic or function blocks or anything like that, but they can put X's in rows and columns to get their idea across of when stuff needs to happen. In the old days, what we would do is we would take that cause and effect and then either translate it into ladder logic or function block or whatever language our customer would allow us to use. But with cause and effect matrix, you can take that matrix and it looks exactly the same in both the programming software and in Excel. So I was already very familiar with the cause and effect. Being able to use it inside of TIA Portal actually was very, very easy. It really doesn't take any programming skill whatsoever. It's more just looking at an Excel and translating it into the graphical editor.
That's excellent. I can see how that can make it easy for you to take what they've given you and put it into code quickly, right? But also it probably reduces the barrier for somebody that kind of troubleshoot the system because now they're looking at something that's not maybe ladder logic, maybe they're not an electrician, they're not familiar with it. They're looking at something that kind of looks like that workbook that process guy put together for you. So I can see where it may have two different advantages there. John, I know I see you've switched over to TIA Portal. So what can you show us in here?
Yeah, I agree with what you just kind of mentioned there, Sean, is the kind of making it easier for the process guy looking at the PLC and getting into more of a graphical representation of something that means something more to them than translating it into ladder logic, especially if you look at the workforce and the programmers today doing more in scripting languages or locking down blocks that are more standard. The cause and effect matrix does give us the opportunity to make transparent some of the control code or status of a certain situation in a nice graphical editor that's actually controlling the process in the PLC. Yeah, I did open up TI Portal so I could make a real quick, short overview of adding the matrix to the PLC, but go ahead with your question.
Well, I was just thinking as you were talking, I wanted to ask Ron, do you see this making making the factory acceptance tests smoother because it's kind of laid out graphically, just like the booklet they gave you?
Absolutely. So what you can do, and John will show you this in a second, when you bring up that cause and effect matrix in the graphic editor, click the monitor all button so you can monitor what's going on. It looks exactly the way it looks in an Excel sheet. So when you're going through FAT, they'll say, okay, let's look at cause one, let's make it happen either through some type of simulation. And then we go across the effect column, and each time we tick one off, we can see it graphically in TIA Portal, so it makes it extremely fast.
Yeah, that's what I was thinking it would. Thank you.
Yeah, so all I wanted to do is just highlight the fact that, I have my standard program in a PLC, and basically it's targeted at any one of the controllers, whether it's a 1200 on the basic or low end, more cost effective, the distributed controller, or even the advanced controllers, all the way up to PC based controllers. It's all of the form factors of the PLC support this, and it's standard. If you look at the Siemens concept of bringing together organization blocks that are interrupt driven, like main program, or cyclic blocks for PID, then you've got your function calls, your FCs that are just like jump to subroutines, and then you got your function block that comes with an instance data block, so that you have a coordinated data associated with that logic. But basically, it's the same as creating a ladder logic or a function block diagram or a graph or a scripting language. You just add a new block to your PLC. And as you can see, I like to do things online to demonstrate the significance of what can be done online with software while I'm connected to the PLC. But FC is just that jump to subroutine, and there's really no data block that's stored with it. And I can do ladder, FBD, statement list is the traditional European programming. SCL is the scripting language that we're seeing more and more workforce people embrace because this can be a little bit more efficient. But if I select the FB, I get a little bit more of the PLC editors following the standard. And that's where I get that cause and effect matrix to select. And right now it doesn't support safety, but we're hoping in the next year or year and a half that we get the ability to also do a safety control cause and effect matrix. Oh, but I just give it a name here, cause and effect matrix, for example. And my intent is only just to show how simple it is to add this to an existing TI Portal project, and how it kind of comes up almost the same way that a ladder logic does, with the ability to parameterize an input, add comments. So the grid was intended to provide the same similar functionality that exists uniformly as a ladder editor or a function block diagram, where I can either pass the variables to the block with input parameters. So I could define a local input here, and then assign that here. We'll just do local in, local out. And basically, just like ladder logic, I can parameterize the cause, give it an instruction, and then define a set or matrix function, and then do the same across the top. Define the output, connect the output, give it an instruction like equal is the easiest one to do for that one. And then basically I've got that these conditions drive to that output.
For the audio only audience, just to kind of paint a picture for you, we got one cause on the left-hand side, like in row 1, column 1, and then we had one effect on the top, right? And so you get that by default. You get one on the left, one on the top, and they make they come together in like cell 1. If you were thinking about Excel, and all John is doing, he's creating tags. The in, out, local in, local out, in, outs. He's just creating new tags and dragging them onto those blocks, and to show not only what will cause this if X equals Y, then what's the effect, what will happen, right?
Yep.
And so and so that graphically, it's very much like working with your first cell inside of an Excel workbook.
Yeah. And again, just like everything else, this block is in my program structure, and I just need to make a call with it so that it is being executed. And then it's going to create an instance data block to store those variables. And then I just merge it into the online running while the PLC's in run mode, and I've got my first cause and effect. And that is how simple it is to basically either roll into programming ladder logic FBD, or now getting started with what is available in this cause and effect matrix. And you can see I'm animated in blue, indicating it's not true. If I were to toggle these variables in, I would get a green box. And I think it's going to be better to kind of turn it over to Ron, because he's got it tied to kind of more of a real application in his tank solution.
All right, so yeah, I've got it running in sort of a tank simulation. I've got PLC sim and the HMI simulation already running. If you've done any of the TI University things, you've already seen this mixed tank quite a bit. And then I've got the cause and effect actually lined up here. Bring that back up. And so side by side, what we can do is look at the HMI on the left, the cause and effect here on the right. And right now we can see that all my causes, my input are high temperature, low level, high level, and the lid switch on the tank. And then my effects are the steam valve, the discharge pump, the agitator, and whether or not I can enable the sequence. And because everything is green, everything is healthy. So Shawn, sort of what you were talking about going through FAT, if we cause one of these causes to happen, we can then just go right across the row there and see what effects are actually being fired. So right now, I'm going to put the steam valve in manual and cause a high temp. So let's put it in manual, open up the valve. I've got simulation running that'll actually give me some valve feedback that it's opened, and then we'll see the temperature transmitter start to climb. And I've got a high temperature at 100 degrees. So we should get an interlock here when we hit 100 degrees. So it won't take but just a second to get there.
Yeah, I like the way that, in the demo that Ron is showing, he's really documented using the comments and the details of what can be laid out in the matrix. So you can really see which each one of these is controlling and modifying. And he's also used the not on the input to reverse the logic of a high temperature. Yeah, so you've got the not there. Yeah, that basically, when it's true, it drops out that condition.
So with the steam valve closed, the temperature is dropped back into the valid range. And so now the steam valve is no longer interlocked. And we can do that with low level. So if I put the mixed tank in manual and the valve discharge. So let's go ahead and just empty the tank and get a low level. And so we can see the low level cause should interlock both the discharge pump and the agitator. You really don't want to run those guys if you've got a low level in the tank. So once we hit a low level, which I think is around 1% or so, there we can see we fired, we got the mixed tank level low alarm. We can see in the cause effect matrix, we have lost our interlocks for the pump and the agitator, and you can see they are both locked as well. So very easy, like you were mentioning in fat, okay, we caused a low level, there are the effects across the top, and at a very graphical way, you can see that they are no longer healthy.
Yeah, I mean, it is very visual. If for the audio audience, you get on the left, low level. When we get that low level, we on the come across the right, the two columns that have the agitator and the discharge pump, those get disabled because we're at a low level. Of course, you don't want to have a run your pump and agitator when it's empty. So,
one other
very
thing to
visual.
point out
Go ahead.
here is, like the agitator actually has two interlocks. We can't have low level, but we also can't have the lid switch. You don't really want the agitator to be able to run if the operator has the lid open. So you can see here, the lid switch is actually satisfied, but the low level is not. So this is how those are called action groups, and that's how you can combine causes for a single effect.
Yeah, I love graphically how it shows that it makes it very easy to understand what's happening.
In Ron's case, if you want to show that logic docked in your project, Ron, and how it's called from main program, you're using variables, right? So that
Absolutely.
this is reusable. And basically, again, there's two ways to use any one of these function blocks. Is you either parameterize it with a local variable, or you, like Ron's doing it properly here by kind of using the local variables that exist inside the call the block, and then that way it's reusable across every tank, right, Ron?
Correct. So if I had 5 mixed tanks that were identical, they all had temperature transmitters and level transmitters and the valve and the pump, I just use this block over and over again and just tie in the different analog signals.
So if you're out there and you're thinking, how does this translate to Allen Bradley? If you have some Allen Bradley experience, it would be very similar to using an add-on instruction where you bring in your, tank one levels into the block in this instance, and then below it, you put the block in a second time, you bring in tank two's variables and
Correct.
so on.
With other than that, Rockwell just doesn't have a cause and effect matrix
Oh, no, they
programming
don't.
language,
Yeah,
but
no.
certainly, yeah, in the AOI, you would have to program that in ladder logic or function block or something like that.
Yep.
And so here's a great example of a cause and effect matrix that I've sort of sanitized here, but this actually came from a process engineering company. And you can see this is the way they document things. They go through all the different high level alarms and low level alarms and vibration, and then you go across and you see what that needs to shut down. And so this is one that we've actually programmed in the field. So very, very useful.
Yeah, that was excellent to show how it really is kind of complicated. Do you use any of their device tags when you do your programming to try to match what they're doing in their
Oh,
cause and effect
absolutely.
matrix?
Yes. Yeah. We try to name things. Process engineers are very particular about how they name their loop IDs and all that. So absolutely, when we're programming, we'll usually create a user-defined type, a PLC data type that, the first, sort of the base tag is the device tag number, and then beyond that, you've got HH alarm and LL alarm and things like that. So yeah, it's easy to find from the cause and effect diagram all the way through the PLC logic.
Yeah, so for the listeners, I mean, these are what you would expect from device tags like PT-7001 or PT-8002. And LCV-2000. So these are your standard device tags, and they have this. They have the descriptions. They have all of this information right in the Excel spreadsheet. So Ron translates that and puts that into the code. So so if you know the process, you know the code.
Yep, exactly.
Or at
And
least the
like we
tags
said,
in the
we had
code.
to use this cause and effect when we were going through FAT. All right, let's cause a freshwater flow rate high
Mhm.
level, and then did it actually put flow control valve 4101 into manual, and did it put 4102 into manual? So easy to follow along because the code
You
looks
can see it.
exactly the
Yeah.
same. Yeah.
That's awesome.
Yeah. So what's cool about this, Shawn, is it was released about a year and a half ago. It's included in TI Portal. It's not an add-on package. It was basically just provided as an additional PLC editor language, following the IEC standards associated with lateral logic, FBD, and others. And it's supporting or supported within all of the controllers without any additional licensing.
Let me clarify that. So you're saying if I'm a 1200 customer and I have the basic version of TIA Portal, I'm going to be able to use this in my 1200 without buying another license?
Correct. Yes.
Wow, that's nice.
And kind of the thought process was, because it is a simpler, more basic logic, it could be applied into applications that aren't traditional PLCs in the field, where a low cost 1200 type PLC would really be cost effective. And then being able to program it with a real simple matrix that anybody not in the industry can completely understand. So it's really significantly pretty powerful tool that's part of the TI Portal Basic 1200 and scales all the way up to the other one. So once you do the block like Ron's done here, you drag and drop it to the library, give it to the team, and that's part of the standard offering.
It's a lot of people, they want to implement something new on a smaller system so they can get their arms around it, right? They typically, if it's a 50,000 IO project, they're not going to try something new on it. It's in most cases, right? Sometimes you have to, but so the fact that it's supported in the TI Portal Basic for the S7 1200, that means somebody could say, you know what, I can try it on a smaller system, get my feet wet, and again, that package is so inexpensive, especially with the awesome starter kits you guys have that I'm always telling my students about. You know, I mean, it's affordable if you wanted to learn at home and update your skills. So that's why I think that's kind of what draw. And as an instructor, I'm constantly thinking people have S7 1500s at work, but they can only afford a 1200 at home.
Yeah.
This gives them a way to test it, even if they were not going to be deploying it on a 1500. And I think from Ron's screen, maybe Ron, you can comment on this. Did you find that this was supported in PLC Sim?
Oh yeah, we are absolutely running it in PLC Sim right now. That's what that's what I have running here for all of this.
That's awesome. So that's the free. If you're not if the audience members aren't familiar, this is a free emulator or simulator, PLC simulator that comes with TIA Portal. It's not extra. It just comes with it. We covered this in my course. It's actually really easy to use. It's such a nice add-on. And John, I think it also simulates HMI too. I mean, that's what we're looking at here, right?
Yeah, absolutely. Like Ron mentioned, that's what I was using on my demo when I started. I always use PLC Sim because it supports all the controllers. It has some PLC simulator tags that I can do. And when I simulate the HMI, what's great about the TI Portal is if the HMI starts up and launches and it looks for the PLC on the LAN network, but finds PLC Sim is launched, it'll connect automatically to PLC Sim. So it's almost automatically picking its path to this PLC Sim application instead of looking for the hardware. So like you have the capability of vetting the PLC together with the HMI, with safety, with cause and effect matrix, with motion control, all on your computer without any hardware.
That's really an advantage. Even if you just had the basic version of TIA Portal, you're going to have the
Correct.
basic version of WinCC for the basic panels. So you'll be able to simulate the HMI. You have PLC Sim to simulate the PLC. So you can test everything out right on your. It's just a great value. And then, of course, you also have the other packages as well for the comfort panels and the unified comfort. But yeah, it's not, and that's exactly what Ron's here was looking at Ron's screen here, and the tank, and that's what he's doing right here.
Yeah, and while we're on the topic of the HMI, the other thing that's nice about cause and effect, so if the operator's staring at this screen and he sees the lock symbol here on the agitator and he's not familiar, okay, why is the agitator interlocked? I've created just a quick pop-up using that cause and effect that's in the logic and just showing, okay, it's interlocked because we've got a tank level low. So very quickly, the operator even can know why the agitator is not being allowed to run.
Yeah,
Nice.
the cause and effect matrix, I think it provides all these tags and statuses, and that's what Ron mapped to a pop-up and filled that out. Eventually, one day it'd be ideal if we have, once we have our unified HMIs launched, is some standard interfaces that bring up the cause and effect matrix directly from the PLC. But right now, Ron just pulled the status bits out of the data
Correct.
block.
Yeah, or even like the, you can do the code view
Yep.
in the HMIs. If we could do a code view with a cause and effect, that's on my wish list.
Yeah, that's on my list too as well.
That would be awesome. That would really be awesome.
The other thing is Ron and I have kind of set up, along with Don Wilson, TI University. I don't know if you've ever seen this, Shawn, the Siemens TI University.
I've seen. I haven't actually gone through the classes, but yeah, I've seen it. Yep.
Okay. So yeah, for your listeners, if they do jump to this TI University, it's a Siemens training, getting started page, and there's some fundamentals on TI Portal. Ron's done some deep dive comparisons of what the other guys do with AOIs and Studio 5000 or Logix Designer versus TI Portal. And then on the Expressway, that's where Ron's done some videos, and one of them is the cause and effect matrix. It's about an hour segment where you go through and use that same tank project, download it, and configure a cause and effect matrix, exactly like what Ron did. Right, Ron?
That is correct. I actually looked at it this morning. I had to go grab the seed project.
Now, are these on demand? They sound like they're on demand. Is it there a registration cost for some of these, or explain how that works? Because we haven't covered that in the podcast before.
Yes. So the test drive is you register for a session, and the dates are shown here. It's basically once a month. And the same with the 1-day session live with Ron, you register. But these are on demand. The TIA topics on the Expressway are on demand. So you register and you take any one of these general courses that are loaded up there now. And you can download a trial version of V17 and do a 21-day. There's a link right there that shows you how to do it. And you can do any one of these 5 topics with Ron as he steps through some of these more advanced topics related to TI Portal.
That's
and I
excellent.
believe all 3 of them are free of charge too. Is that correct, John?
Yes. Yep. Absolutely.
Now, I like to emphasize with my students, the software you get free for 21 days, but it's you can't get 21 days with version 17 and then get 21 days with 16 and then get 21 days with 18. So keep that in mind. You don't want to actually run and start using the software until you're actually ready. I know a lot of us will get everything set up and it'll be 3 months before we actually I dive into the training. So I like to warn it. That's another place where VMware is your friend. You can take a snapshot in case you ever have to roll back, if you don't get through your course. So, but keep that in mind because, and again, the starter packs are extremely affordable and come with either a 1-year license or a full lifetime license of the software. So check those out as well.
Yeah. So Shawn, your users can also create a login with Siemens Industry Support and go to Industry Premium Portal. And there they can get to TI Portal in the cloud. And in that case, they can actually do a V17, a V16, and a V15 and kind of jump through different things in the cloud. And eventually we are working to get this released so that they can pay for the use of TI Portal in the cloud by the month or per use. We're hoping to get that released here in the US soon as well. But there's some good options out there, from the ability to get more information on the TI University with these topics, and as well get started in some of the cloud activities.
Yeah, that's awesome. I think that's the future. Some people are going to be doing their work in the cloud. I think most of the three of us will probably always have our high-end laptops or desktops that we do everything on locally. But in some instances, it makes more sense, especially if you're learning, to do everything in the cloud. So no matter what PC you're on, that's one of the things I like about Office in the cloud is, I can pull up Word on any computer and just pick up where I left off. So it's definitely a nice option to have.
Yeah, I'm finding that you recognize the things that, like you said, I want to do this across a couple of my computers, my office computer versus my Siemens laptop PG, like what you have there, Ron, or things that I want to maintain locally. And we're doing the same thing with TI Portal, licensing it locally, licensing it as a subscription, annual subscription, as a bundle for certain applications, and then the availability of starting to do some stuff in the cloud. I think we'll see a mix of those three licensing models as we go forward with some of this stuff. So, but I think that's kind of the overview of what we wanted to kind of highlight. Shawn, I think it was pretty exciting to give us a chance to look at this editor in a little bit more detail and have someone like Ron on board to show you, example of an application.
Yeah, Ron, I really appreciate you coming on with John to show us, because you've actually deployed this. You had that sanitized worksheet from the customer that kind of showed like a real world example of what they've given you and why this is such a good fit. So really appreciate you coming on to talk about that. I really didn't have an understanding. I know John had said and kind of initially explained it when we did the V17 podcast last year, but this really drove it home for me. And the fact that it is included is just great, because now I could teach all my students and they'll just have it. It'll just be there. So I think that's awesome as well. And if you're listening to the podcast, you don't have the video, please feel free to check out the video later on. There's some great shots in here of how it works. And in any case, just want to thank you both, John and Ron, for coming on the show to take us through the cause and effect matrix.
Appreciate it, Shawn.
Always a pleasure, Shawn. Thank you so much.
Well, I hope you enjoyed that episode, and I want to thank John and Ron both for coming on the show and bringing us up to speed on the cause and effect matrix. Now, if you did enjoy this episode, please consider giving us a like and a sub. And if you know anybody who wants to learn Siemens or Allen Bradley PLCs, please send them over to theautomationschool.com, where you'll find my very affordable training. That said, if you want to follow me or keep in touch, you can do so over at automation.locals.com. And with that, I just want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.